Hi there, thanks for your interest in this video. I'm Anton and my channel is all about getting the most out of your programmable Lego. I'm trying to hack it and discover features that no one has ever told you before and then share them to you. In this video we are going to keyframe animate this bad boy here. It's Stars. It's my favorite robot from the movie Interstellar. We're just going to let him walk. Cartwheeling sadly is not possible because of the limitations there, and he also doesn't have a humor setting yet, but I'm working on that. So we are going to use Python for this, and Python will allow us to animate him like you would animate anything in a program like After Effects or Blender or 3D Max. We're going to use keyframes. Before we start, I'd like to thank my patrons on Patreon. This month they are Andrew, Sana, Job, Bricktie, Kim Seong, Stout, Alvin, Gunnar, Tim, Avnish, Freddy, Diego, and Arthur. They help make this tutorial video possible. You can join them by clicking the link in the top left of this video, and if you join me on Patreon, you will get previews and access to building instructions. So without further ado, let's dive into it and animate this guy here. First, I'm going to connect my robot through USB, boot it up, then go to code here, and this creates a word blocks code. My hub is connected, but we want Python code, so let's go create Python. Then all of this, we're going to remove that and use the boilerplate code from my website to get started with keyframe animation. So move to the website, so you can find the boilerplate code if you go to Robot Inventor Tutorials, and then it's somewhere here, so it's this article called Keyframe Animation. If you read it, you find some background information on how this all works. For this video, we're just going to click the link here to the boilerplate code and just copy it all. It's about 300 lines of heavy lifting. There are a lot of comments in there to make all of it understandable. So if you have some time, do take the time to read through it. So now it's copied, we go back to the MINDSTORMS program here and paste all of this. Let's update this script. Animates stars from Interstellar. Okay. Now it says here the real code starts at line 300, so we go. Oh, I'll zoom in a bit. Ding, ding, ding. It's probably easier to read on YouTube. And scroll. You know, my scrolling finger is aching, and we're here at line 300 something. I so wish Lego would allow us to do multi-file Python projects. That would save a lot of scrolling, and I could just import all of the stuff above. But hey, it is like it is. We have to copy and paste. Now, we're all set up to start keyframe animating TARS. Let's hope we have as little face plants as possible. Let's start with defining the motors here. We have 4 motors. You can see them in the upper right corner. They are A, B, E, and F. We are going to define the motors with hub style motors, hub.port.a.motor. So this is maybe you're used to saying a motor is a motor and then something like this, but that's yeah, there is all kind of magic happening if you use this kind of motor under the hood, and I just want raw access to the motors, so I'm using this kind of motor definition, comma, don't forget the commas. We're creating a list here, so make sure you add your commas. We're going to copy this, copy and paste it 4 times. It didn't paste my tabs, sadly. Okay, now we have A, B, E, and F. And just to show you what happens if I move Tars's right arm, you can see in the upper right corner, this is motor A moving. So, and if it moves forward like this, you can see that if it moves forward, you can see the degrees decrease, and if it moves backward, the degrees increase. So arms backward is a positive, arms forward is negative. That's nice to remember later when we do keyframe definitions. So this is, let's make a note here, right arm forward is negative. Yeah, we're starting a bit negative. Tars is starting a bit negative, but it will turn positive soon enough. Now we have motors. We have a nice list of motors to animate, and we will animate them with motor functions. They will be interpolations that we will add later, but first we need to do the keyframes. So the arm keyframes. Keyframes in this system are also a list, and they are a list of tuples. So tuples are in Python are numbers between brackets, so number A, number B, and the first tuple is the time, and the second tuple is the motor angle. So I want the motor to be down here at time 0. Somehow my motors got decalibrated a bit during the programming. They started out alright, but I should probably recalibrate my motors. They are pointing straight down, and you can see up here A and B have about 7 degrees. So for us right now, down is going to be not 0, but minus 7 degrees. Okay, and our shoulder keyframes is also a list of keyframes, and the shoulders start up at time 0, and up is 0 for shoulders. So once we are sure that the shoulders are up and the arms are pointing down, let's take a half a second to push the arms down. So we're pushing the arms straight down, so let's keep the arms pointing down, but let's rotate the shoulders. Oh, this is time, half a second, 500 milliseconds, and let's rotate the shoulders all the way down. So this is okay for a start. For keyframes, these are 2 motor positions that we want to reach at 2 times, and right now we can start defining the motor functions based on the keyframes. So the functions we are defining here are time functions. They will return a number depending on the time of the timer, and the time functions are defined by our keyframe with linear interpolation. So the linear interpolation is a function, is a method that's up there in the boilerplate that I created to interpolate between keyframes. So the motor functions are in the same order as the motor definitions here. So the first motor function will be the arm function, and it will be with the arm keyframes, and the interpolation by default wraps around because most robots have a repeating movement, but we are still designing the movement here, so I'll turn off the wrapping, and so it just does one movement and then stops everything, because we want to avoid those pesky face plants. Now the second, copy this, The second motor is motor B, that's also an arm, but it's built in mirror fashion, so we are going to scale all the keyframe values with a factor of -1, and this will effectively invert everything. Same goes for the shoulders. Shoulder E is regular, shoulder F is inverted. If I did not make any programming mistakes, this little program should push the shoulders down and lift the body. It's very unassuming, but it's a start. Let's have a look at what the model does. Hope we didn't make any programming mistakes. This doesn't do much. What is happening here? What is happening here? This is really strange. Oi, 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 oi. I was going too fast. It's so hard to talk and program at the same time. So I copied the arm keyframes also for the motors. I need to make sure that the shoulders move like shoulders and the arms move like arms. In the real movie, Tars is a real smart robot, but this is just a very, very dumb version of him. So let's try this again. Look at the model. Yes! He is lifting his body off the ground. We have liftoff. That's awesome. So this is a far cry from walking, but it's nice to have a liftoff here. And let's continue the programming and make sure that after we have liftoff that we swing the body forward. Okay, we'll do this by creating more keyframes. So once we have liftoff, the next thing we can do is swing the body forward. So let's take, let's swing it quite quickly. So let's take 200 milliseconds. So that's a fifth of a second to swing the body all the way forward to about 35 degrees. I think that should work. And let's make sure that the shoulders here stay down. Stay down! Stay down! Okay, the shoulders stay down and the body swings forward. Let's see where that brings us. Nice! Okay, body has swung forward and the shoulders stayed down. I think I'd like the body to swing forward a bit farther. And then we'll drop the shoulders and Tars will land, well, maybe not so much farther, maybe dropping. Actually looks quite good. Let's see what happens if we just drop the shoulders and leave it at this. Okay, let's go back to programming. So next we are going to keep the arms where they are. Let's take another half second, keep the arms where they are, like this, and in the same period of time, add another half second, drop the shoulders or lift the shoulders, and I hope Tars lands on his feet right now. Let's see if this program does any good. Okay. Yes. Swing forward. Woo! I almost had Tars fall on the back of his head. This is not where we want him to be. So he landed, but I want him to stand on his feet. Let's see how we can make Tars stand on his feet. Okay, the way we will make Tars stand on his feet is by pushing the arms back again and then lifting the body forward. So again, what we will do here is keep the arms in place. Let's take another half second for this. Keep the arms in place and push the shoulders back down and see if this pushes Tars on his feet. Ooh. Would he faceplant or would he not? Would he? Oh, I forgot to switch cameras, but it worked. You just couldn't see it. Let's try it again, so you can completely see what really happens. Yes, we have liftoff, swing forward, landing on his feet. Boom! We are halfway the walking cycle actually. So once this is done, the next step is to retract the shoulders back up and swing the arms forward to end the walking cycle. Now, okay, let's go back to Python here. Let's take another half second. In a later phase you can tune all these delays. For now I'm just using half seconds, except for this one because I wanted the forward swing to be a bit stronger. Half second. Should the arms stay the same? Yes, the arms should stay where they are. And actually these keyframes don't do much anymore, so you can also comment them out. And retract the shoulders. So at 2200 milliseconds and 2.2 seconds into the walk, I want my arms to be retracted again. So we do it risky and swing the arms forward. Why not? Let's make a risky, bold move here and swing the arms back where we want them, while also keeping the shoulders up. So we added 2 keyframes. Ooh, will that work? Or will he faceplant? Okay, 2 keyframes. Let's see what happens. On your feet, soldier! Oh no! I forgot commas. These commas are going to be the death of me sometime. Okay. Try again. Play and over to the model view. Soldier was still on his feet. Okay, move forward. Push back. On your feet. Ow! So, apparently, I don't know what happened. It wasn't stable enough, and lifting the arms there or retracting the shoulders too fast pushed Tars back on his on his back arms. So let's try that again. We're here. Okay, so what you saw, I hope you saw it too, is because I lifted the shoulders too fast, Tars fell over backward. The lazy robot that he is. He just wants to lay down, right? No, it's gravity pulling him down. So, the thing we need to do is add another keyframe, and here, so these are the arms stretched out. Let's keep the arms stretched out for a bit before retracting it. So this gives Tars half a second to stabilize with the arms stretched out before going there, and then we have to move everything up a second. So at 32,200, that's 500 more, still be at 0, and delay all of this with half a second. Let's see if the half second time to stabilize is enough to make Tars stay on his feet. Okay, on your feet again, soldier. Boom, we have liftoff, forward swing, land, pull the arms. Wow, we almost have a full walking cycle. So the only thing left to do here is have the arms, well, they could actually stay where they are. Look what happens. So the arms are back home and the shoulders are back home too, because this value is the same as this value. So we could actually try and start wrapping this around and see if we have a full walking cycle. So here we'll just turn wrapping on, and this will loop the complete animation. Okay, would it work or would it faceplant? Wow, we have a walking animation, I think. It was almost face planted, saved by the USB cable, but still this is pretty near a walking cycle. So let's do the same and remove the USB cable and just push the button here to start the program. See if without the USB cable as a savior it still walks. Wow, it does. Wow, that's a near faceplant. I probably have to tune the keyframes a little bit more because it's really unstable there. But it's a pretty neat walking animation. So this actually concludes this video about keyframe animation. I hope you saw the power of it. I can really easily animate this robot. Not much programming needed. The boilerplate, my keyframe animation boilerplate, does most of the heavy lifting, so you can focus on tuning the motor positions and creating a supple animation that with a behavior that you really like. Well, thanks for watching so far. Remember to subscribe. Click the cards in the upper left corner to go to the website where the boilerplate is. There is also a card with my Patreon website where you can support me if you want more tutorials like this, more nice boilerplate codes for your robots. And I hope to see you again in the next video. Thank you. Bye bye.